In this lecture, we're going to cover two sections. We're going to start with section 5.4 about polynomials in several variables. This is just more math with polynomials, but now involving more than one variable. So the only thing is that we need to take care of the different variables and their powers. So we're going to start with evaluating polynomials in several variables. So we're going to solve example 1. Example 1 on page 371 is we're going to evaluate the following polynomial through 2x cubed y plus xy squared plus 7x minus 3 for x equals -2 and y equals 3. So we're going to evaluate this polynomial. This is a polynomial because the powers of these variables are only whole numbers. So that's the reason it's a polynomial. Remember, if you have a power that is not a whole number, then you don't have a polynomial. And this is a polynomial with 4 terms. And this is a polynomial in 2 variables because now we have x and y. And to evaluate, we're gonna follow the same rules as before. We're gonna replace every x with -2 in this case, and we're gonna replace every y with 3 to be able to do the full evaluation. So y is gonna be here, and y is also here. So let's do that. I'm gonna use parentheses to indicate multiplications as usual. So we have 2 times x is -2, and that's raised to the power, the third power. Then we have y is 3 plus x is again -2. Y is 3 now to the second power plus 7, x is -2, and finally minus 3. So we do the operations in the order that we have learned. So we're going to start with the exponential expression. So we're going to rewrite every exponential expression as a multiplication. So this -2 to the third power is -2 times -2 times -2. Then we have times 3 plus -2, and this square is written as 3 times 3. So this corresponds to this, and then the rest is going to be just the same. So let's start doing these multiplications. So we have 2 times 3 is going to be 6, and negative times negative times negative is going to be -8. So this is the result of the first term. So now the second term, we have 3 times 3 is going to be 9, and we have -2 here. So positive times negative is going to be negative. 2 times 9 is going to be 18. Positive times negative is going to be negative. 7 times 2 is going to be 14. Then we have -3 here. And also positive times negative is going to be negative. So this is going to be -48, -18, -14, -3. So you are adding 4 numbers that are negative. So you just add 48, 18, 40, and 3. And you're going to get 83. So 83 with negative sign because all these numbers are, they have a negative sign. So now we're going to work on another different kind of problem. So we're going to work on describing polynomials in 2 variables. So this is on page 371. So we're going to use terminology. So we're going to solve one example to see this. So we're going to work on example 2 on page 372, it says that we're going to determine the coefficient. Determine the coefficient of each term, the degree of each term, and the degree of the polynomial, and the degree of the polynomial. And what is the polynomial? The polynomial is 7x squared y cubed minus 17 x to the 4 y squared plus xy minus 6y squared plus 9. So this is my polynomial in two variables. So the variables are x and y. So we're gonna write every term vertically now. So we have 7x squared y cubed negative 17x squared y squared plus xy minus 6y squared plus 9. So this is my polynomial written vertically in a vertical format. So, and then these are the terms. So I'm going to write now the coefficients of each term. So the coefficient is, in this case, is just 7, then is negative 17, then is positive 1, negative 6, and positive 9. So these are the coefficients. Now we're going to find the degree of each term. Is going to be the sum of the exponents of the variables in every term. So in here we have x is raised to the second power and y is raised to the third power. So the degree in this case is going to be 5. In the second case, x is raised to the fourth power and y to the second power. So the degree is going to be 6. Then in this next case, we have x to the first power plus y to the first power. So we have ones here, remember. We don't see them, but they are there. So this is a term with degree 2. Then in the next case, we only have y. That's 2. You can say here that the degree of x is 0 and the degree of y is 2. So the final degree is 2. And you can say here that the degree of x is 0, the degree of y is 0. So the degree of this term is 0. So you look for the highest number. So this is going to be the degree of the polynomial. So this is a polynomial of degree 6. So that's example 2. So now we're going to do some, we're going to start doing polynomial math. So let me just work polynomial math. So we have here polynomial math. So we're going to start adding and subtracting polynomials in several variables. So adding and subtracting polynomials, adding and subtracting polynomials in several variables. So this is on page 372. So we're going to solve a couple of examples. So we have example 3 on page 372, and we're going to add the following. We have 6xy squared minus 5xy plus 7 plus 9xy squared plus 2xy minus 6. So we're going to write this addition vertically. So I'm going to remove parentheses first. So I'm going to write 6xy squared minus 5xy plus 7. And then I'm going to align the corresponding terms, the like terms on the same column. So I have here xy squared. I have here xy squared. So we need to write here 9xy squared. We are just removing the parentheses. The sign is positive, so we don't need to change the sign or anything inside of this parenthesis. So now I have 2xy. So this is the column for xy. Finally, the last column is for the constant term. So I'm going to write here negative 6. So we end up with 15xy squared. So be careful about the exponents of each variable. Then we're going to do the math with the coefficients as usual. So we have negative 5, positive 2 is going to be negative 3xy. Finally, 7 minus 6 is going to be positive 1. So that's example 3. Now we're going to work example 4. That's on page 372. And now we're going to do a subtraction. We're going to perform the following operation. We have 5x cubed minus 9x squared y plus 3xy squared minus 4 minus 3x cubed minus 6x squared y minus 2xy squared plus 3. So that's the subtraction that we're going to perform. So we're going to remove parentheses first. So 5x cubed minus 9x squared y plus 3xy squared minus 4. Then we're going to write the second polynomial, but since this is a subtraction, we're going to switch the sign of every term inside of the parentheses. We're going to switch those signs. So this 3 is positive inside of the parentheses, so it's going to become negative once we remove the parentheses, and it's cube, x cubed goes in this column. Then this negative is going to become positive 6x squared y. Just check that you are aligning like terms. Then this negative becomes positive 2xy squared, and this positive becomes negative 3. So we proceed with now the addition, because we already changed signs. So 5 minus 3 is going to be 2x cubed, and negative 9 plus 6 is going to be negative 3x squared y. 3 plus 2 is going to be 5xy squared, and then we are adding 2 negatives, so we're going to get negative 7. So that's addition and subtraction. We're going to continue with our polynomial math. We're going to multiply polynomials now. So the section on multiplying polynomials, the part of the section, is on page, let me see, 373. So now we're going to work 2 examples. We're going to work 3 examples, and then you're going to have an exercise set to work on. So let's see. So we're going to start with example 5 on page 373. So we're going to multiply 2 monomials in this case, 7x squared y and 5x cubed y squared. The rules are the same again. We're going to multiply coefficients. Multiply coefficients, and we're going to multiply like variables by using the rules for exponents that we learned from previous sections. So we're going to start multiplying coefficients, so 7 times 5. Then we're going to multiply like variables. So first we have x here, exponent 2, and x here, exponent 3. So we're going to add those exponents. Then we're going to multiply y's, exponent 1 in the first case, plus exponent 2 in the second case. So the final answer is going to be 35x to the 5th power, y to the 3rd power. So that's example 5. Now let's work example 6. Example 6 is on page 373. So we're going to multiply now a monomial and a trinomial. So we have 3x squared y that multiplies 4x cubed y squared minus 6x squared y plus 2. So we're going to apply the distributive properties. So we're going to multiply this monomial by any of the 3 terms, by all of the 3 terms inside of the parentheses. So let's write this multiplication. So we start with 3x squared y that multiplies 4x cubed y squared. That's the first product. Then we're going to write again 3x squared y, and now we're going to write the second term inside of the parentheses, 6x squared y, negative 6. Then we're going to write again 3x squared y, and we're going to multiply that by 2, which is the last term. So we proceed now applying our rules. So we multiply coefficients. 3 times 4 is going to be 12. X is going to be raised to the 2 plus 3 is going to be 5. Y is going to be raised to the 3rd power because 1 plus 2 is going to be 3. Then we're going to have here positive times negative. That should be negative. Negative 3 times 6 is going to be 18. And x is going to be raised to the 4th power because 2 plus 2 is 2. 2 plus 2 is 4, sorry. Y is going to be raised to the 2nd power because 1 plus 1 is 2. Finally, positive 3 times positive 2 is going to be 6. And then we have just x squared and y as the variables that are in one of the factors. Okay, then you have example 7 on your book. So you work example 7 by yourself. If you have questions, let me know. We're going to end up with example 8 on page 374. So we're going to start with the first case. We're going to multiply. In the first case, we have just 4x squared y plus 3y, and this is equal to 4x squared y, sorry, not equal, this is multiplied by 4x squared y minus 3y. So you can check that the first term is the same, the second term is almost the same, the only difference is the sign. So we have conjugates, we can use a shortcut. So the shortcut is just, this is A and this is B, so we're gonna square the first term and then minus the square of the second term. So this is gonna be 4 squared because this exponent affects every factor inside of the parentheses. So this is 4 squared. Then we have x squared and y squared minus 3 squared and y squared. So finally, we're going to have 16x to the 4 y squared minus 9y squared. So that's part A. So now part B. So we have part B is just x plus y that multiplies x squared minus xy plus y squared. So now we have the product of two polynomials in two variables. So we're going to write the first polynomial vertically, and then we're going to multiply each term by the second polynomial. So we're following the same rules as before. So we're going to apply the distributive property here. So we need to multiply x and x squared and x and xy and x and y squared and y and x squared and y and xy and y squared. So x times x is going to be x cubed. X times positive times negative is going to be negative. X times x is going to be x squared and also multiply by y. Then x times y squared, this is positive, it's going to be x times y squared. So you just put those variables together. Now in the second row we have x squared times y. I'm going to write first the x and then the y. So the order of the factors doesn't change the result. So you can write y squared, y x squared or x squared y. I needed to write in the same order to be able to combine like terms. Positive times negative is going to be negative x. We don't have only x here. And y times y is going to be y squared. Finally, y times y squared is going to be just y to the third power. Then we combine like terms. You see that they are aligned diagonally. So you can add them in that way. And you can see that these two cancel to each other because they have different sign. And these cancel to each other because they have different size. So you end up only with x cubed plus y cubed. So that's the the final answer for this problem. So now I'm going to assign you the first set of problems for today's lecture. So you have 5.4 exercise set on page 375. So you're gonna evaluate for x equals 2 and y equals -3. Let me see. This is exercise number 6. So this is 3x squared y minus 4y plus 5. So this is just the directions for exercise 6. Then we're gonna, in the remaining exercises, you're gonna perform the indicated operation and obviously simplify. So you have problem 14 is just these two polynomials that are going to be added. 6x to the 4 y squared minus 10 x squared y squared plus 7xy. You're going to add -12 x to the 4 y squared minus 3 x squared y squared minus xy. Then we have problem 20. Problem 20 is now a subtraction. So you have x cubed minus y cubed. That's the first polynomial, the first. Then the second one is going to be -6 x cubed plus x squared y minus xy squared plus 2y cubed. So this is a subtraction. Then we have two multiplications. So we have 32 is just 7xy multiplying a binomial ax plus 3y, and finally 62 is just another multiplication. So it's 7xy squared minus 10y that multiplies 7xy squared plus 10y. So this is your work for this first section. I'm going to continue in a minute. We're going to start the last section that we're going to cover in this lecture. This section is 5.5. It's about dividing polynomials. So this is another operation on polynomials that we need to learn. So we're going to need some rules for exponents now to deal with the division. So let me just summarize the rules that we're going to be using in this section. So I have here the three rules that we're going to use. These rules are very similar to the ones that we learned for multiplication. So now the quotient, that is the division, the quotient rule for exponents is when you are dividing you're dividing terms that have the same base and just different exponents. So you are dividing two different powers of the same base. You're gonna write the base and then you're gonna subtract the exponents. So you're gonna subtract the exponent from the denominator. You're gonna subtract the exponent that is from the denominator from the exponent that is coming from the numerator. So you're gonna have just b to the m minus n in this case, because m is in the numerator, n is in the denominator. And it's important that this base is different than 0. There is another exponent rule. So the zero exponent rule is when you raise to the 0 power any base, the answer is just 1. And again, that base should be different than 0. Finally, we have the quotients to powers rule for exponents. And this is when you have a quotient, a fraction raised to a power. You can sort of distribute the exponent into the numerator and the denominator. So this is like breaking the base again. So this is the base. The base is a fraction. So we break the base into bases now. We have one base to be now the numerator, and the other base is going to be the denominator, and you raise each of those to the exponent that we had in the first place. So we're going to solve some examples here to apply these rules, and then we're going to go directly to divide polynomials. So first, we learn a little bit about the rules for exponents. We follow the same approach when we start multiplying polynomials. So before multiplying, we learn the rules. Now, before dividing, we're going to learn also the rules. So I'm going to start with example 1 from page 380. So let me write this down for you, for your notes. So I have example 1 on page 380. So I'm going to divide each expression. So this is on page 380. So I have here first the first one. So I have 2 to the 8 divided by 2 to the 4. So that's my first quotient. So the base is 2 in this case, and the base is 2 in this other case. So we write the base, and then we subtract. We get the difference of the exponent. So we have the exponent from the numerator minus the exponent from the denominator. So the answer is going to be 2 to the 4. 2 to the 4 can be written as 2 times 2 times 2 times 2, and this is going to be 16. Then we have another case, x to the 13th power over x to the 3rd power. Now the base is x, and since this is a division, we're going to subtract the exponent. So we're going to write the exponent from the numerator minus the exponent from the denominator. So this is going to be x to the 10th power. We have one more case. We have y to the 15th power over y. So here y is the base. The exponent from the numerator is 15 minus the exponent from the denominator is 1. So the answer is y to the 14th power. Okay, now we're going to work example 2. Example 2 is on page 380. So we're going to simplify the following expressions. We're going to start with the first one. We have 7 to the 0. So the base is 7 and is different than 0. So the answer is 1. In the next case, we have -5 to the 0. So the base is -5 is different than 0. Then the answer is 1. In the next case, we have -5 to the 0. So now the base is only 5. In this case, the base was -5. Now the base in this case is 5 only. So you're gonna keep the sign because it's outside of the power. It's outside of the base. And you're gonna write just 1 because 5 to the 0 is 1. Then we have 10 is 10 times x to the 0. So here we have the base is just x. So x to the 0 is gonna be 1 and is multiplied by 10. So the answer is 10. Finally, we have 10x to the 0. Now 10x is the base, not only x as before. 10x is the base, so the answer is just 1. So that's example 2. So we are just applying the rules for exponents. In the next part of the section, we're going to start dividing polynomials. So let's work a couple of more examples to be ready for division of polynomials. So I'm going to work now on example 3 on page 381. So we're gonna simplify. So in the first case, I have x to the 4 and this is a square. So now my base is x over 4. So I'm going to break the base. So I'm going to distribute. So I'm going to distribute the exponent. So affecting now one part of the base and the other part of the base. So now I'm going to simplify by just rewriting this 4 squared as 16, because 4 times 4 is 16. Then I have another case. So now I have x squared over 5 to the 3rd power. So here I'm going to break the base and you're going to get x squared to the 3rd power and 5 to the 3rd power. So you apply the rule where you are getting the power of a power. So you multiply exponents. And in this case, you just rewrite this as 5 times 5 times 5. So this is going to be x to the 6 over 125. And finally, we have 2a over b to the 4 2a cubed. And this is raised to the 5th power. So now we have this base, and we're gonna break the base. So we're gonna distribute the exponent. So we're gonna have the numerator raised to that exponent and the denominator raised to the same power. So now we're gonna distribute the exponent again into the factors that are composing the numerator and the denominator. So 2 is gonna be raised to the 5th, and a cubed is gonna be raised to the 5th, and b to the 4 is going to continue be raised to the 5th power. To simplify, we're going to write 2 as the product of 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Then we have a to the 15th power and b to the 20th power. So this product of numbers 2's, you're gonna get 32 a to the 15 over b to the 20th. So those are the examples that we needed to work on to practice the new rules, the rules for exponents when we have quotients, when you have fractions of division. So now we're gonna start doing the actual division of polynomials. So we're gonna start the section of the subsection dividing monomials. So we're going to start first with monomials as we did with the multiplication. So the rules are very simple, are similar to the multiplication of monomials. So we're going to divide coefficients. So we need our fraction math. Remember, this is important. And then at the same time, we're going to divide variables. So we're going to use the exponent rules. The exponent rules that we learned in the previous part of this lecture, and also the rules that we learned from previous sections. So we're going to start, we're going to work on example 4 on page 382. We're going to divide first these two monomials. I'm going to write negative 12x to the 8 over 4x squared. So I have now the division of two monomials. One monomial is in the numerator and the other monomial is in the denominator. So the rules are divide coefficients. So I'm going to write negative 12 over 4. So that's the first part of the rule. And the other part is we divide variables. So we divide variables. So we're gonna get the difference of the exponents for each of the variables that are involved. So then we're gonna get just negative 3. So you simplify negative 12 over 4 x to the 6th power. So that's part A. Part B, we're gonna divide now 2x cubed over 8x cubed. So we start first dividing coefficients and dividing the variable 3 minus 3. So we're gonna get 2 over 8 x to the 0. You can simplify 2 over 8 by dividing by 2 both the numerator and the denominator. So you're gonna get 1 over 4 because x to the 0 is 1. So now another case is 15x to the 5th y to the 4 over 3x squared y. So first we divide coefficients, we divide variables. So x is gonna be, we're gonna have x to the 5th minus x, the exponent is gonna be the difference, 5 minus 2. For y is gonna be the difference, 4 minus 1. So this is gonna be 5x cubed y cubed. So this is division of monomials. I'm gonna continue straight ahead just for you to get ready for the exercise set and to finish this lecture. So I'm going to work now the next part of the section. We're gonna divide a polynomial by a monomial. So this is on page 383. So for this, you only need to divide each term of the polynomial by the monomial. So we're gonna divide each term in the numerator by the denominator. So we're gonna break a huge fraction in several fractions. So you're gonna see that now. I'm going to work on example 5. Example 5 on page 384. We're gonna find the quotient. We're gonna find the quotient, and we have a negative 12 x to the 8th plus 4x to the 6th minus ax cubed, and we're gonna divide this by 4x squared. So this is the polynomial, and this is the monomial. The best way to work this is writing any division as a fraction in this case, when you are dividing by monomial. So I'm going to write the numerator is just the first polynomial. So that's the numerator, and I'm going to write the denominator is gonna be, in this case, the monomial. Now I'm going to break the fractions. So I'm going to create 3 fractions. So every term is going to be divided by the monomial in the denominator. So that's the first one. Then I have 4x to the 6 over 4x squared. And then I'm going to write the last one. And all of them are divided by 4x squared. So that's the best way to treat these problems. So now you can apply the rules that we have for division of monomials. So we're going to divide coefficients first. So negative 12 over 4. And then we divide variables by subtracting exponents. That's the first case. Then we have 4 over 4. And we're going to have x to the 6 minus 2. And then finally, I have negative a over 4, x to the 3 minus 2. We simplify these things now. So negative 12 over 4 is going to be negative 3. X to the 6th power. This is going to be just 1. You can write 1, it's fine. And then x to the 4. And then finally, negative 2x to the 1. You can write also 1, 3 minus 2. And then you remove the ones that are as coefficients or as exponents. So your final answer is just this one, without ones in the as exponents or without one as coefficient. So that's example 5. Let me work one more example, and maybe you're gonna be ready for your assignment work. So this is example 6 on page 384. So we have 16 x to the 5th minus 9x to the 4 plus ax cubed over 2x cubed. So we are working example 6. So we're going to break the fraction. So if we break the fraction, we're going to get 16x to the 5th over 2x cubed minus 9x to the 4 over 2x cubed plus ax cubed over 2x cubed. So now we're going to treat each of these independently. So you're going to start with the first fraction, 16 over 2. These are the coefficients. And then we divide the variables, 5 minus 3. Remember, you just deal with the exponents. In the second case, we have minus 9 over 2, x to the 4 minus 3, plus a over 2, x to the 3 minus 3. So the final answer is going to be ax squared minus 9 over 2 x to the 1, which is just x, plus 4, and then x to the 0 is just 1. So that's example 6. One more example and we finish the lecture corresponding to this day. So this is example 7 on page 384. So now we have to divide 15x to the 5th, y to the 4, minus 3x cubed y squared plus 9x squared y. I'm going to divide this by 3x squared y. So we are dividing a polynomial in 2 variables by a monomial in 2 variables too. So let's write this as a fraction. So 15 x to the 5th, y to the 4. I can start writing right away the fractions that are going to result for breaking these numerators. I'm going to have the second term, negative 3x cubed y squared over the monomial plus 9x squared y over the monomial. Then we're going to do our coefficient math. 15 divided by 3 is going to be 5. Then we're going to write x. 5 minus 2 is going to be 3. Then we're going to write y. 4 minus 1 is going to be 3. Then negative 3 over 3 is going to be negative 1. You can write 1. Then we have x. 3 minus 2 is 1. And we have y. 2 minus 1 is 1. And finally, 9 over 3 is going to be 3. X is going to be 2 minus 2. Y is going to be 1 minus 1. So this is going to be x to the 0. Y to the 0 is just 1. So usually what we do in math is when you have the same factor on top and at the bottom of a fraction, you just remove those factors. You cancel those factors. But in this case, we are applying our rules for exponents. So the final answer is just 5x cubed y cubed minus xy plus 3. So now you have 5.5 exercise set on page 385. So we have 6 exercises for you. I have number 6 is just y to the 19th to y to the 6th. Then we have 22 is just negative 6 to the 0 plus negative 6 to the 0. And then we have 36. You have x cubed y squared over 2z. And you're going to simplify this. You're going to apply the corresponding rule. Then we have 48. This is just negative 15 x to the 16th power y squared over 45 x squared y squared. And then we have problem 70. Problem 70 is 9x cubed plus 12 x squared minus 3x over 3x, and problem 78 is just ax to the 6 y cubed minus 12 x to the a y squared minus 4x to the 14 y to the 6 over negative 4x to the 6 y squared. So I think all of these problems are important. But if you don't have enough time to work on this, at least work problem 70 and problem 78. So this is the end of this lecture. So we need to cover a little bit more about chapter 5. So you are not ready to work on the quiz, but you can start working on your homework 5. So you can work part of the homework 5, but you are not ready to work on quiz 5. So if you have questions, send me an email with the problem that you want to check with me. Send me screenshots of your work, and we're going to continue with this chapter the next time.